yeah, you behind the screen. Thanks for watching. Yeah, thanks for watching Newbold's math videos. Lots of blessings on your head. Okay, here we go. What the? Sorry, wrong church. Okay, so number 8. Thanks for watching. So we have discontinuity. There we go. Thanks for watching this. Ace it before the test. Practice test. So let's see here. So first of all, you're going to have one like this on the test. You got to be able to factor. What are factors of 21? Pause me if you don't remember. Pause me if you don't remember. And then try. And then see if you got it right. Did you pause me? Okay, so factors of 21 is going to be 7 times 3 is 21. Positive 7. Positive. That's an awful 7, Newbold. Sorry. Positive 7 minus 3 is a positive 4, so we factored it right. Oh, wow. So the x plus 7s are going to cancel. That's cray-cray. It's crazy. So that means that we were going to have a vertical asymptote at -7, but it's actually going to be the discontinuity, the removable discontinuity. That's called the hole. So it's going to be -7 for our removable discontinuity. And then the simplest form, well, when we say cancel, there's still an invisible 1 there, don't forget that. And so that invisible 1 is going to matter now because the x plus 7s are going to go away. This is actually a big key that people forget. And so the rest of our equation in simplest form is just going to be 1 over x minus 3. Nice. So then, now to get the y value of the whole, we're going to go in and plug in the x value. And when you do that, you get -7 minus 3 is a -10. So 1 divided by -10. And I tried to do lots of variations of how you might type this in with spaces. Hopefully I capture everybody's inputs there. Okay, the x-intercept, let's see. So the x-intercept, you set the top equal to 0, or set y equal to 0. So you could set y equal to 0. But when you do that, you end up multiplying x minus 3 to the other side. It just goes away, and you end up with 0 equals 1, which it doesn't. So this y equals 0 actually becomes none. And then also x-intercept, none. The other reason is probably because the horizontal asymptote. Remember, top is less than bottom, so y equals 0. Then we have the y-intercept, so you set the x equal to 0. When you set the x equal to 0, you just get 1 over -3. So set x equal to 0, and you get y equals 1 over -3. Or -1/3, you can write it either way there, negative in front or here. I'll accept either answer of those on the practice test and on the test. Ooh, this is interesting. So the vertical asymptote, right? Well, it was going to be at the whole, which was -7, but that's the whole. So we are only going to have a vertical asymptote. Remember, set the bottom equal to 0. So we're only going to have a vertical asymptote at add 3 to the other side, x equals 3. And you can look at the graph on this. So x equals 3 is our vertical asymptote. And it was going to be -7, but we're just going to say, oh no, that became the whole. So we're just going to put a none here. That gets the answer none, okay? Or you can put none here and 3 here. It'll accept it both ways. Vertical asymptote, or horizontal again, is just 0. Now the domain is all real numbers from -infinity to either 3 or the whole, whatever it hits first. So it's going to hit the -7 first. So it's going to -infinity to -7, union with -7 to 3, and union with 3 to infinity. And if you use decimals down below and graphed it, you would see -7 and then 3. It would be tricky, you'd have to know the holes there, but yep. So basically, if I was going to graph this sucker, then I'd have a hole way over here at -7, -1/10, so a little hole right here. An asymptote here, and then an asymptote at 3, 1, 2, 3. A lot of times it's easier to see the domain after you graph it. So we have go through the hole, come along, we have a y-intercept at -1/3, which is right about there. And so the graph is going to go through there and then down here like this. and then up here and to the right like this. And now you can see the domain is all real numbers from negative infinity, and it hits the hole, it has to jump over, so -7, and union with -7 to 3, and union with 3 to infinity, where 3 is your vertical asymptote that we're skipping. So hopefully that helps you understand how we do the domain there. Negative infinity to -7, -7 to 3, and then 3 to infinity. Nice, nice. And in the sign chart, it's negative till we get to the 3, then the graph jumps up here to positive. So it's going to go negative, then positive, and it's the 3 that we have to skip over. Nice, nice. Okay, there we go. So that's for number 8. Number 9 is just going to be doing the graphing. Whoa, attacked by the dog! So number 9 is just going to be graphing. Whoa, sorry about that. Okay, so you can use Desmos, you can plug them right in there. So for example, x plus 3 over x minus 2, I would use parentheses. So x plus 3 divided by x plus 2. If you don't use parentheses, you will get it wrong. So please, please, please use parentheses. So that was supposed to be, oh, I've got my mouse on the couch. Okay, so then we got a x plus 3 and a minus 2, I believe. Nice, nice. X plus 3 over x minus 2. So there's Desmos. So we're looking for a vertical asymptote, remember, at 2. And a horizontal looks like at about 1. Nice. So then we look through all these graphs and see where there is a vertical asymptote at 2 and a horizontal at about 1. Nice. So that's B. So I would say that problem number 4 is going to be B. And so that's how you do those ones. You're going to match each of those in there. Awesome. You can use Desmos or just go through your previous work of all that stuff that you did and use that to help you choose the right graph. So it'd be like, well, who has a hole at, oh, -3. Oh, I remember who has a hole at -3. It was the ones that canceled at -3. And so, oh yeah, that was number 8 had a hole at -3. That was the one that we just did. And so since there's a hole at -3 for number 8, I would probably say then that number 8 has a hole at -3, so number 8 is D. Make sense? Make sense? Where else is there another hole? Isn't there a hole at -7? Oh yeah, there was a hole at -7, and that's graph C. Uh-oh. That was the one that canceled here. Sorry. So that's actually 8 should be. 8 should be D. Hope you keep on watching this video so you can fix that. So sorry. It should be 7 should be C. And then the other one that canceled was this one, D. So 6 should be D because that was the +3s that canceled, and 8 should be C because that was the -7 that canceled. That's right, that's right. Okay, so keep on finishing those. Here's another inequality. It's the same exact one, actually, I think, as number 3. Let's see here. Yeah, I just said greater than instead of -9, +4. So I did less than there. So now, for this one, it's just going to be the other direction. Yeah, so the other direction will be going the other way. So if we can even remember what that was, can you remember? So it's going to be parenthesis -infinity to that -4, and it was in the bottom. So it'll be a parenthesis there, and union with, and then where else is it positive? Well, not between -4 and 9, but after that, so +9. Oh, and a bracket around. No, there's no equal to. So parentheses 9 to infinity. And then always parentheses for infinities. Always parentheses for infinities. It doesn't have an equal to, so everything is parentheses. And last but not least, number 11. Where are we at for time? We're doing good. So here's our last one here for the practice test. So number 11, here we go. So we do want to factor the sucker first before we can do our inequality and test points. Of course, this is going to factor into 2 and 4. 2 times 4 is 8, and 2 plus 4 is 6. So then we're going to have a crazy number of test points here to do. Maybe we could show you the cheater-peter method with graphic. So it's going to be the top is -6. It does say equal to, so solid dot. And then the -4 and then the -2. Nice, nice, nice. And really, to be honest with you, these are open hole because they're in the bottom. Really, the pattern is just going to alternate. Negative, positive, negative, positive, or positive, negative, positive, negative. So if you even just chose a test point of 0, which is to the right of -2, and we plug that sucker in, that would help us get all the answers really fast, right? So that goes away, that goes away. When you plug in a 0, that goes away. So just 6/8, which are both positive. And if this is positive, then it's going to be negative, positive, negative. No way, that easy? Yep. You can even graph this sucker, and you'll see it go below, above, below, above. And then, watch out, there's a bracket at -6. There's a bracket there. So don't forget our brackets. So we'll go like -infinity to -6. Oh, no, parenthesis, -infinity to 6. And then bracket. Oh, wait, what are we doing? Oh, we're just doing negative numbers, right? I jumped the gun because I need to help my wife cook. Sorry about that. So let's do black. Okay, so we only want where it's negative. So it's going to be parenthesis from -infinity to bracket -6. Nice. Because that's only where it's less than 0. Remember, just negative numbers. Number 10 was only positive numbers. Positive numbers. Okay, so -infinity to -6. Don't forget the bracket. And union with, and where else is it negative? Oh, it's negative from -4 to -2. So we go parenthesis, parenthesis, -4 to -2. Nice, nice. So email if you get stuck. Thanks for watching. You behind the screen, thanks for watching. Max, say thanks behind the screen. Thanks for watching. Come on, get your math done. Don't hide under that table. Don't hide from your math. Max, you do your math. Come here. Come here, buddy. Come here. Yeah, you do your math. You come here. Good boy. Good boy. Alright, thanks for watching, you guys. Hope you guys study hard. Have a good day. Thanks for watching. Ace the test next time. Thanks for watching.